Hey there, geometry students. That's right. It's me, Mr. Troll, here at my own home, here to deliver you a geometry lesson from my dining room table. Okay, so today's goal is to familiarize you guys with this concept of density, which is the second or third lesson that you get in Canvas. Okay, so if you don't know what density is, it's really helpful for not only helping you understand things you need to understand for chemistry or physics or your other science classes, it's just a good thing to understand for real life because the concept of density comes up all the time. Once I start to explain what it is, it'll make sense. Okay? A good way to start understanding density is by looking at the formula. So I would write this down if I were you. The formula is D for density equals M for mass divided by V for volume. Now, if you ever forget that formula, the easy way to remember it. It was my chemistry professor in college. His name was Mr. Bascom. He taught me this, that density is a broken heart, okay? Because you get the M and the V, M over V. You can see the M is the top of the heart and the V is the bottom of the heart. So if you ever forget the formula for density, just remember that it equals a broken heart. Okay, M stands for what again? Mass. And V stands for volume. So the density of something is the ratio of its mass divided by its volume. So mass per unit volume. What are some units of mass? A unit of mass would be like a gram. Okay, you've heard things are measured in grams. That's how much mass it has. If it is 1 gram, it's about the same mass as a paperclip. So it doesn't weigh very much. It doesn't have very much matter. If it's a kilogram, that's another way of measuring mass. That's 1,000 grams. Kilo is 1,000, right? So 1,000 grams, that's about 2.2 pounds, a little more than 2 pounds, okay, worth of mass. Okay, volume is a measurement of how much space something takes up. And this unit you guys just finished, you were working on the formula to find the volume of a cylinder or the volume of a pyramid. There's a bunch of different shapes you can actually calculate the volume of. It's the measurement of the amount of three-dimensional space something occupies or fills. Okay, so the volume can be measured in, hopefully you guys know by now, you can measure it in cubic inches. Okay, you can measure it in cubic feet. You can measure it in cubic, any unit of length, like a centimeter or a meter or even a kilometer. Any unit of length, you can cube it and you have a unit of volume. Okay. Also, you can measure volume in liters or milliliters. Those are what you'll use in chemistry mainly. A liter is, I don't know, that's about a quart or about a fourth of a gallon, roughly. You can also measure it in quarts or in gallons. Those are all measurements of volume. Okay. So speaking of inches cubed and feet cubed, I happen to have a cubic inch right here. Okay. I made this in my garage about a half an hour ago. Why isn't this thing focusing? Come on now. Focus. There we go. Okay. So this wooden cube is exactly 1 inch by 1 inch by 1 inch. Okay, 1 inch by 1 inch by 1 inch cube. So since each edge measures 1 inch, this takes up exactly 1 cubic inch of volume. Okay. Does it have to be this shape? No, this could be a sphere or a cylinder, or if it were made of Play-Doh, I could make it into any shape I want to. It would still take up this amount of volume. It doesn't have to be a cube to take up a cubic inch of volume. It's just how much space it takes up. Okay? I happen to have another cubic inch right here. Okay? This is not made of wood, obviously. It's made of metal. It's actually a bunch of little magnets stuck together. Okay? Made of mostly iron and some nickel, I think. Anyway, it takes up the same volume as the wooden cube because it is an inch by an inch by an inch. These things are the same dimensions, height, width, and length. Okay, so this also takes up 1 cubic inch of volume. Okay, however, these things do not have the same mass. Can you guess which one has more mass? If you guess the metal one, the magnetic one, you'd be correct. Okay, it's a lot heavier. Okay, you can imagine how much heavier this is. Okay, if you've ever held wood or held metal, you know that metal is a lot heavier than wood. In other words, so another way to think of it is metal has more mass, but this metal cube has more mass than the wooden cube, but it takes up the same amount of volume. That means that metal is more dense. It has a larger density value. Okay, so larger mass divided by the same volume, it's more dense. So it's pretty obvious that metal is denser than wood just because it's heavier. Okay, so the density basically measures how heavy something is, how much matter is packed in to this unit of volume. Here, there isn't as much matter packed in because it's not as dense. It's light. It floats even, right? Why does it float? Because it's less dense than water. Metal is denser than water, so metal will sink. Okay, so different materials, metal, wood, any material has a density. Okay, and you can usually just look those densities up, which is what I did. Let me show you what materials I looked up, and we'll see if you can guess which one's the most dense. Okay, so I looked up these, how many are there? 6 materials: water, concrete, styrofoam, wood, air, and steel. Spruce wood, because there's different kinds of woods. I chose spruce since that's a common tree we have up here in Alaska. Okay, so which of these materials, water, concrete, styrofoam, wood, air, steel, do you think is the most dense? Which one do you think is the least dense? See if you could rank them from 1 to 6, 1 being the most dense, 6 being the least dense. Why don't you pause the video and see if you can rank it yourself? 1 to 6, 1 is the most dense, 6 is the least dense. I will let you take the time right now to rank those. Okay, pause the video. I am going to start in 3 seconds. This is your chance to pause. 3, 2, 1, 0. Let's reveal. Okay, water is this dense, 997 kilograms per meter cubed. Okay, a cubic meter is how much volume is that? That's like how much volume a cube would take up if it were 1 meter by 1 meter by 1 meter instead of an inch by an inch by an inch. You guys know how long a meter is, right? That's like almost 3 feet. It's about half my height. Okay, so that's a lot of water. That would weigh 997 kilograms. That's like over 2,000 pounds. That's over a ton. Okay, water's pretty dense. Concrete is denser, 2,400 kilograms. Okay, more than twice as dense as water. Styrofoam, not very dense, only 50 kilograms per meter cube. 50 kilograms, that's a little over 100 pounds. Most of you guys could lift that, but not very easily. A meter cubed of styrofoam is still a lot heavier than a lot of people can lift. Wood is 450 kilograms. Okay, so far, what floats? Concrete doesn't float because it's more dense than water. Styrofoam and wood, they'll float for sure. We kind of know that because those are less dense than water. What about air? Air floats. It's only 1.225 kilograms per meter cubed. Okay, so a meter cubed of air still weighs a little bit more than 2 pounds. Okay, that's hard to visualize. Air doesn't have any weight. It just floats, but it still has a mass of 1.225 kilograms. So it does still have matter in it. And then steel, of course, is extremely dense. 8,000 kilograms, way denser than anything else on this list. Okay, so what's the most dense? Steel, number 1. Number 2 is concrete. Number 3 is water. 4 is wood. 5 is styrofoam. And 6 is air. So if you had it in that order, good job. +1 respect. Comment below how you did. How did you do on the density ranking? Did you get it right? Did you get it wrong? Let me know in the comments. Okay, so hopefully you have an idea of density. Density is literally how light or how heavy something is, and we measure it by looking at an amount of mass per a unit of volume. Okay, I'm going to go ahead and end this video right here because this has already gone on for almost 10 minutes. I'm going to follow this up with another video. We're going to do some example problems. What kind of problems are you going to have to do with density?